All right, sorry, people who are gone, my recording stopped, so this is part 2 of the recording. We are on this bottom section now, and this is called the ambiguous case for the law of sines. Sometimes, I don't go over this in geometry, but sometimes you will end up getting some funky weird thing going on with your triangle, and here's what happens, okay? The information that you're given, you're always given angle A, and you're given B, and you're given side A, which is opposite angle A, right? If that's the information you're given two sides that are opposite each other, and then you're given side A. Sometimes you will have the case where this A that's opposite this angle A, they will make it too short, which means he's not long enough. He's not long enough to even touch this bottom side here. Do you see that? Like that triangle's not, that third side, that side opposite the angle is not long enough to touch down on that bottom side, and it doesn't even make a triangle, right? And that occurs when this happens. When the value of little a, which is the side A, is less than the value of B times sine of A. That's when that will happen, okay? All right, if I go over here and I'm looking at little a in relationship to B and capital A, if little a is exactly the same as B times sine of A, then that means it's coming down and it's touching, but it's actually making a right angle. So it's making one solution, one triangle that's actually a right triangle, okay? Now look at this one over here. This is where you have two solutions, okay? Wrap your brain around this one. Ready? If little a, which is the side that's opposite from angle A, if this little a is bigger than B times sine of A, what can happen is you have this side that's touching over here, but I can loop him around and have him touch over here as well. So I can have him making two different triangles depending on how I'm swinging that third side. Does that make sense? Okay, so if that's the case, then I have two triangles that are occurring, okay? And that's just kind of a weird thing that happens with the law of sines. So the thing that you want to look at always is when you're dealing with A and you're dealing with B sine of A, or really any side and any angle that's opposite it with a third side, right? With another side, you want to check that side and see what he is in relationship to B sine of A. Okay? So is he bigger than, is he equal to, or is he less than? And that will tell you how many solutions that he has. Does that make sense? That is if A is already less than B. If A is greater than B, then you're only ever going to have one solution, right? Okay? That would be like the case of, like, let's say A is 30 degrees and B is 7 and A is 12, right? This scenario is going to happen. We have A is 30 degrees, which is an acute angle, okay? But capital A is bigger than, or excuse me, lowercase a is bigger than B. So we already have this thing happening. We know that there's only one solution that's going to occur, right? Okay. But if A is smaller than B, if it was the other way around, like if capital A was 30, lowercase b is 7, and lowercase a is 5, then I have to check each one of these scenarios to figure out how many solutions I'm dealing with, how many triangles I have. Okay? All you have to do is read the chart. You just do the computation, read the chart to figure out what you're dealing with. Okay? Case 2, if you have A being larger than a 90-degree angle, like let's say A is 110 degrees, capital A is 110 degrees, and let's say lowercase a is 12 and lowercase b is 17. Which one of these scenarios am I dealing with? Do I have one solution or no solutions?
No solution.
How do you know?
Because A is smaller.
A is smaller than B, so I'm going to have no solutions, which means since I have this big angle here for an obtuse angle, this side A is not big enough to touch down on the other side. Does that make sense? Okay, so you just read the chart and you see those are the scenarios that you're dealing with, okay? So if you're solving a triangle and you get no solutions, like when you're solving it, it's probably because you didn't check one of these rules to see that he had no solutions to start with. You'll get like a domain error in your calculator if you try to solve it and it doesn't actually have a solution, okay? So hold on to this chart. I wish I had those as two separate pages. Anyway, let's go to the back side. Let's talk about these guys here. So, example 2, let's just see how many solutions he has. Given a possible triangle ABC, A is 6, B is 7, capital A is 65. Okay, so let's look at capital A first. Capital A is 65. So which chart am I looking at? The top one here or the bottom one here? Capital A is 65. I'm looking at the top one because A is less than 90, yeah? Okay, now let's look here and let's say lowercase a is 6 and lowercase b is 7. So I'm just going to write this at the top here. A is 65, lowercase a is 6, lowercase b is 7. Did I flip those around?
No.
Nope, we're good. Okay, so now we're going to check these two guys in relationship to that one and see which of those three that we're looking at. Okay, A is smaller than B, right?
Yeah.
So I'm going to have one of these guys happening. So we've got to look at A in comparison to B sine of A. So A in comparison to B times sine of A. A is 6, and we want to take 7 times sine of 65. What is 7 times sine of 65? 6.34. So A is smaller than 6.34, right? We have that. So what's happening here? No solutions. We don't have a triangle. It's doing one of these. It's doing, if A is here at 65 degrees, B is here at 7, this side is 6, and it's trying its hardest to like touch down over here, but it can't because it's too short, right? Okay, so we have that happening with example 2. There's no solutions. I just tested this thing over there. A in comparison to B times sine of A. Since lowercase a is smaller than that, he can't touch down on the other side. Okay, those are the weird things that's going to happen with this section. Okay.
Well, we're trying to find.
What?
Are we on example 2?
Yeah. Are you okay, Elena? Can I scroll back?
I just need the number.
6.34. Okay. So, yeah, that's this one. Given a possible triangle ABC, find angle B. Find angle B. We can't. No solutions. You cannot find angle B because there is no solution. If you want to do a circle with a line through it, this does not even make a triangle. We can't even find angle B. Because angle B would be over here, right? If 7 is here, angle B would be across from that. Well, B doesn't even have two sides that are coming together, right? He can't come together because he's too short. Okay, so just go through those two charts and check out the relationship and see whether he has a triangle or whether he doesn't have a triangle. Okay, good? What's up? Right here?
Yeah. What is that one for?
What, this information?
Yeah.
This is for the one that we just did. I just wrote it at the top, or wrote it on this page. So you could see it because we're on two separate pages. So you didn't have to flip back and forth. I just wrote it like that. What? No, there's no solutions. Because A is a value of 6, B times sine of A is 6.34. So we have this scenario going on. A is less than B times sine of A, which means there's no solutions. That triangle's not coming together. He ends up looking like this because this side of 6 is shorter than this side of 7. So that's not going to work. Okay? I should erase what?
You
Just erased what?
back up.
Ah! Just erased what? Where? That's fine. Yeah, I know. That's fine. That's all right. Okay. Let's go down to example 3. An airplane A takes off from carrier B and flies in a straight line for 12 kilometers. Yeah, right there. This guy right here. He's starting here and he's flying this way for 12 kilometers. Ooh, that was a straight line. Yee! Right? Now I'm erased. Starting at A. Is he starting at A? Airplane A takes off from carrier B. No. You're reading and I'm not. He starts here.
It's like
Start and he's like doing one of those, right? Because he like it's like the airplane up in the sky is like pooping out an airplane, right? Yeah, that's exactly what's happening.
Exactly.
It's exactly what's happening. It's pooping another airplane out and then he's flying, right?
No, that's a boat.
That's a boat?
That's
Oh, that makes me sad. That makes me sad. But doesn't that happen where airplanes poop out other airplanes, right?
Yeah.
Yeah, but this is a boat. Okay. I'm just not looking at the picture.
It's like helicopter thing.
It's like the carrier. That's a boat. I have no idea what's going
So there he's starting, and then later he's 12 kilometers later.
What's that movie called with Tom?
Yeah, I know what you're talking. Top Flight,
Gun.
Top Gun. There you go. Don't worry about
The
it.
second
Don't
movie is
worry
supposed to be coming out this year.
Really? Huh.
Anyway.
At that instant, an observer on destroyer C, located 5 kilometers here, notes that the angle determined by the carrier, the destroyer, the vertex, and the plane is 37 degrees. Whatever. This is 37. They are wanting us to find.
Angle A.
B.
How far is the plane from the destroyer? They want us to find B. Yee. Man, oh man. Man, oh man. So, we have to use the law of sines. Great. We need some things that are opposite each other. What's the pair that I know? Like the grouping that I know?
37 and 12.
37 and 12, those are across from each other. That's the grouping that I know. So I want to do, if I do sine of something over something, sine of what?
37 opposite over hypotenuse.
Nope, don't even do a hypotenuse opposite. That's all right triangles. Okay, sine 37 over 12 equals, but the only other thing that I know is 5, right? So I have to put 5 on the bottom here. And this is sine of A. So I'm not even finding B. I'm not even finding what I want. I have to find this guy first. Okay, all right, now this one's a little bit harder because, check this out. 5 times sine of 37 is the one loop, right? But the other loop is 12 times sine of A. Yeah?
Negative.
You're gonna have to do inverse sine, but what do you do first? Before you do that, divide by 12. We have to get the 12 over to the other side.
Yeah, that's exactly what I
So in a sine of A is equal to this guy. Right? What is that guy? 5 times sine of 37 divided by 12. What is it? 0.251.
Yeah.
Okay, and now I want to find angle A. And always when the angle is trapped inside of here, always, you have to do that inverse sine.
Which is 14.
So take inverse sine of that number, and A is what? 14.5. Let's do 15 degrees. Because when the angle is what you're solving for, and the angle is trapped inside of sine, to get it out, you have to do the inverse. Okay? We did not have to do that up above because we were solving for a side. We had the angle. Here we don't have the angle, and we're solving for the angle. Does that make sense? Yeah? Okay, so let's go with 15 degrees for A. I'm going to get rid of some of my loopy stuff over here. So 15 degrees is this guy. Now, what do we have to do? We have to find B, but what do we have to do first?
You can add and then subtract.
Yeah, 37 and 15 is 52 degrees, right? If we add those two together, and we subtract that from 180, 128. So this is 128 degrees. That's what he is. Yeah? Okay, now we want to do the law of sines on him.
Hold up. So sine A, because you already know it.
Right? Let's do sine of 37 and 12. Why would we want to use that grouping instead of 15 and 5? Because they gave it to us and 15 is rounded. So let's use the same one that we did before. Let's do sine of 37 over 12 equals sine of what? 128 over B. Okay? So I'm not going to write out all the work. What would you do?
Well, wouldn't you use sine of 128 anyways?
What do you mean?
Or wait, were you talking about the first one?
I'm talking about like using sine of 37 over 12 rather than using sine of 15 over 5. Yeah, like this first part here, you want to make sure that you use the stuff that you originally had. So multiply these together and divide by sine of 37. So 12 sine of 128 divided by sine of 37. Can I get away with not writing that out? B is 15.7 kilometers. Okay. Always angles I round to the nearest degree. Always the sides of the triangle I round to the nearest tenth. So 1 decimal place. That's just always the way that it goes. Okay. How are we doing? Is this okay?
No.
Sine A over A equals sine B over B. Okay. Is this one gonna have an answer?
I don't know. We ain't sure yet. No.
4? Example 4 is not gonna have an answer?
So, do we have to look at 35 to decide which chart, right?
What? Yes. Yes. Okay, so let's go back up. This is the information that we're given. We're given A is 35, and we have 7.5 and 12. So let's go up to the chart. So I have A is 35 degrees, little a is 7.5, and B is 12. Okay, so we have 35 degrees. Which chart are you looking at?
One.
We're looking at the top chart, right? Because we're looking at an angle that's bigger than... let me get rid of this stuff.
Yeah. Oh my god.
We're looking at an angle that's smaller than 90 degrees, right? Because 35 is smaller than 90 degrees, so we're going to look at that chart, okay? Now, is A smaller than B, or is A bigger than B?
A smaller.
A is smaller than B, so we got one of these three things happening, okay? So now we look at the relationship between A and B times sine of A. So we do 7.5 in comparison to 12 times sine of 35. What is 12 sine 35? 6.88. Okay.
Which two are we looking at?
A in comparison to B times sine of A. Okay. So 7.5 in comparison to 6.88.
It's greater than.
It's greater than. So what's happening here?
I thought you said square root of that.
We have two solutions going on. Two solutions going on. Oh my heavens. Okay, and we're going to cheat.
Hold on. I thought you don't like to cheat. 6.88 is
Always like
6.88 is smaller than A. So we have this relationship. No, wrong. This relationship going on. Yeah? Okay, so it is a two solution one. Right? Two solutions. Okay, we're going to cheat. We're not going to solve this one. Any of the ones that come out with two solutions, we're going to solve. Because I won't make you solve it on the homework
Are we
assignment.
done for the day?
Okay. Solving triangle. This one has two solutions. And we're going to not solve them. Because I won't make you solve them on the homework assignment. Two solutions. Now, do you see how those two solutions are put together? 35 degrees is this guy right here. And that 7.5 can swing here or it can swing there, right? Okay, that's how he can, that's how he looks.
Oh, I remember doing this.
Okay.
You gotta get
We'll
a
stop
good
there.
start on
We'll
the
stop
week.
there. We'll stop there. Okay. But I'm gonna give you the homework assignment. Okay. You should be able to do, if you so choose, the entire front side. Nope, it's this page right here. You should be able to do the entire front side of here, 1 through 8, if you so choose. The back side, you don't know how to do that yet. But the front side, you know how to do. So if you so choose, you can start on that. This homework, we will turn it in on Wednesday. But there's that, okay? I gotta, come on.